Number 51 asks us to find the inverse of this function. So what we're going to do for starters is just sketch a graph of what this looks like so we can get a handle on what the domain and the range are for this. They also tell us for this that x should be less than or equal to -2. So to help sketch a graph for this, we have a positive x squared, so we know it opens up. So we're going to be going for a range from something to infinity, but to find out where that is, we need to find the vertex. So remember, the vertex is -b over 2a, -4 over 2 times 1 is -2. Okay, so we have our vertex at -2. If I plug that into my function, I can get the y value. (4 minus 8 minus 1 is -5. So our vertex is at -2, -5. And again, I got that by doing -b over 2a like we did back in chapter 1 or chapter 2. So now that I have that, I know my graph looks something more or less like this. I don't really care about the intercepts. I just care about the domain and range. So looking at this, the domain, they actually said that we only want x less than or equal to -2. So just this left part of the parabola that I have here. So that's going to be -infinity to -2. And the range, looking at it, goes from -5 upwards. So -5 to infinity. Remember, domain is x values, range is y. Now, to find the inverse, it's a little trickier here because when we go to set this equal to y equals x squared plus 4x minus 1. All right, that's step 1. We swap the x's and y's. X equals y squared plus 4y minus 1. It's not as easy to solve for y as it was in the other ones. So what I'm going to do, because it's a quadratic, because it has a squared, I'm going to move everything to one side and get 0 on the other. So y squared plus 4y minus 1 minus x equals 0. Okay? One more thing I'll do here. I'll write this as minus parentheses 1 plus x so that I have that factored out. Okay, so looking at this, it looks a little strange because it has x's and y's, but it still is a quadratic equation. And note that if we have a quadratic equation, we can always use the quadratic formula, where a is 1, b is 4, and c is this whole thing right here, negative parentheses 1 plus x, right? Because it's a quadratic, we can use the quadratic formula. So let's use the quadratic formula with that and see what we get. Y equals -b plus or minus the square root of b squared minus 4ac. And I'm going to go ahead and just distribute that minus sign. All right, it was negative parentheses 1 plus x, so I'm just going to write it as -1 minus x, all over 2a. And let's simplify this. -4 plus or minus the square root of 16. Distribute that minus 4 through the parentheses, you get plus 4 plus 4x, all over 2. -4 plus or minus square root of 20 plus 4x, all over 2. And we can take the 4 out of that square root, -4 plus or minus, if I factor a 4 out of this, it would be 5 plus x. And we can take the 4 out as a 2 since it's underneath the square root. So -4 plus or minus 2 square root of 5 plus x, all over 2. All right, if I take a 2 out of the top, then I can cancel top and bottom with the 2's. And I get that f inverse of x is -2 plus or minus square root of 5 plus x. Now we need to be careful. We can't just keep the plus and the minus. We need to decide which one is appropriate for this problem by looking at the domain and range. So earlier, we said the domain and range was that, but when we do our inverse, we know those get swapped. So the domain of the inverse is -5 to infinity. The range of the inverse is -infinity to -2. So if we're looking at -5 to infinity, on this problem here. So to help determine whether we want the plus or the minus here, because we don't want both, if we look back up at the graph with this domain and range in mind, remember that graphically this is a reflection about the line y equals x. So our inverse is going to look something like this, which if you look at it, it's kind of like the square root function, but it looks like it's upside down. And so because it's upside down, that's been reflected over the x-axis, which is going to give us a negative here that we want, a negative. And our domain restriction, because we swapped the domain and range, is right here, -5 to infinity. Or you could write it as an inequality, like x less than or equal to, or sorry, x greater than or equal to -5. So the idea is we knew to keep the minus on the plus or minus, because looking back up at the graph, if we do our little reflection in the line y equals x, this reflection is an upside down square root curve. And the square root curve, if you flip it in the x-axis, that's going to be a negative in front of the square root. So it's kind of a tough problem, but the idea is just bringing all those pieces together.